So at the end of the last video, we're trying to use the first derivative test to figure out where this function y has a relative minimum or a relative maximum. So we took the first derivative, we set it equal to 0. We're going to solve this just the same way that we were solving those polynomial inequalities. So I've marked on my number line the two places where y prime equals 0, and I'm going to test a number from each point. It turns out that if I plug in a number to the derivative, notice I've labeled this derivative. I care about the sign of the derivative, so label your number line with what you care about. If I plug in a number less than -2, I find out that that interval is positive. If I plug in a 0, I get a derivative as -12, which is negative. If I plug in a bigger number, I get positive. So I can make my conclusion. Y is a relative maximum at x equals -2 because the derivative was positive, and now changes to negative. So y is a relative maximum at x equals -2 because y prime changes from positive to negative. And then y prime also has a relative minimum at x equals +2 because at +2, y prime changes from negative to positive. So here's a second example. We want to find when this function y has relative minimums or relative maximums. Again, we're going to look at the derivative, figure out where the derivative is positive, where the derivative is negative, and then we can use the first derivative test to tell us where the relative extreme values are. This one is it's similar to the first one, but the algebra is a little trickier. This is not strictly a polynomial. It's got this exponential function in here. So I'm going to start by taking the derivative. Don't forget to use the product rule. And now I have here's my y prime. There we go. I want to find out when y prime is 0 because those are the numbers I'm going to mark on the number line. Notice that the only way to decide when this equation is true is to factor. And I have a common factor of e to the x, so I factor e to the x out, and I'm going to collect everything else together. So now I have e to the x times this quantity, x squared plus 2x minus 3. I hope you'll notice that that is a trinomial of degree 2 that can factor. So here's my new equation, x plus 3 times x minus 1 times e to the x equals 0. And I have two zeros, -3 and 1. This guy is never equal to 0, so he doesn't contribute any zeros to our solution set. So again, I'm using the first derivative test. It means I care about the sign of the first derivative. So I've labeled my number line with the first derivative. I've labeled my number line with the two values I found, the two values of x that make y prime equal to 0. And now I can plug in some numbers, and I find out that my derivative is positive for numbers less than 0. It's negative for numbers between -3 and 1, and positive for numbers bigger than 0. So here's my conclusion. There we go, I'll get out of the way. Y is a relative maximum at x equals -3 because y prime changes sign from positive to negative there. And you can see at -3, y prime was positive and now becomes negative. And similarly, y has a relative minimum at x equals 1 because y prime changes sign from positive to negative there. Alright, then the next section on your notes is for concavity. We know that a function f is increasing wherever f prime is positive. Now we can actually find out about concavity. We talked about it in class. Concave up means it would hold water if it got rained on. Concave down means it would protect you from the rain if you were standing underneath it. A curve is concave up anywhere the second derivative is positive. Curve is concave down anywhere the second derivative is negative. An inflection point is a place on the curve where the concavity changes, and we can find one of those anytime the second derivative changes sign. So just because the second derivative equals 0 doesn't promise that I'm going to have a point of inflection. My second derivative needs to change sign. We'll see an example in the next video.